thank you so much for your enthusiasm in coming today. I know a whole lot of you have already worked with the older Ecologic exhibition. This time we've focused very much on climate change and water management in Sydney. We've done this simply because when we did the last Ecologic exhibition in 2001, scientists were just then starting to say, we believe there's a link between what humans are doing and what the climate is doing, the change that we're seeing. These days, the evidence is overwhelming, and 98% of climate scientists, and those are people who work in the field, who publish peer-reviewed papers, who talk and live and breathe this all day, every day, all night, 98% of them will say it is humans that are causing the climate to change. However, we didn't want to browbeat people with this. So with this exhibition, I've taken the attitude that we say, okay, we've got a statement. Carbon dioxide levels are rising exponentially. Then we have the question, so what? And then the next question, so what should we do about it? So that is the basis on which I have created this exhibition. So we're treading fairly softly. We're acknowledging that people have different opinions. Climate change is a topic that raises really strong emotion in people. I've already had some pretty nasty emails. And you'll see that on the intranet I have actually posted a statement about the museum's position on climate change science. Our position is that we are very, very excited about presenting to the public the work of climate change scientists, because it is really important that Australians get this information so that they can participate in a meaningful way in the sort of dialogue and the decisions that our society needs to undertake. So if we move over here, we'll have a look at the first pod. This part of the exhibition, the front part of the exhibition, is what we call the carbon half of the exhibition. You can see the major spine of the exhibition is this large graph showing carbon dioxide levels. This one here, going all the way through, you can see it follows what carbon dioxide has been doing over the last 400,000 years. And you can see that carbon dioxide has gone up and it has come down again. Where it's come down, that's where there were ice ages over that time. Now, on this plinth, we talk about carbon dioxide levels between 10,000 years ago and 400,000 years ago. And you can see that it has gone up and down. You can see that the temperature, which is indicated in yellow, has also gone up and down. But you see that there is a very strong link between carbon dioxide concentration and temperatures. And this is what scientists are worried about, because if you look way over there, you can see that carbon dioxide levels have gone far higher than they've been in the last 800,000 years. And scientists are really concerned that this is going to cause a problem for us because the temperature might go up with it. All of this information has been gained from Antarctic ice bubbles. They're fantastic because they're little time capsules that landed 800,000 years ago. And scientists can now dig them up. They actually send cores down into the ice. They cut up all the ice in slivers and they analyse those bubbles and look at what's in it. And that's how they know what the carbon dioxide levels were doing. They know what the temperature was simply because they look at the ratio of carbon 13 to carbon 14, and that allows them to work out what the temperature was. But this plinth here looks at all the natural causes of climate change. We've got meteorites, we've got volcanoes, we've got wobbles in the Earth's orbit. All of these can cause the changes that have occurred here. Now, this lava comes from Mount Vesuvius. It's part of our collection. I was very excited when I found this in a crate out at Castle Hill. This lava here comes from France. Our meteorites came from Western Australia, and the trilobite and the ammonite are fossils. They're real fossils. People are allowed to touch them. We hope they won't steal them. Please keep an eye on people if they're really trying to pull them off that plinth. They are glued down with, I've been told, incredibly strong glue. But they are animals that died out in the Permian extinction. At that time, it's known that carbon dioxide levels were really high, and that's what scientists are worried about, because in the Permian extinction, 90% of all life on Earth died, and they're worried that we're sending ourselves back there. When was it? It was 251 million years ago. So it doesn't actually fit on that timeline, but it's a lovely example of animals that died out because they couldn't adapt to climate change. What I forgot to mention was that there's a picture of a footprint there. It's a 20,000-year-old footprint. It was made in Lake Mungo, in the mud at Lake Mungo, by people who lived through climate change as we came out of the last ice age. Lake Mungo is out in western New South Wales. It was a huge lake. It supported Indigenous people for 25,000 years. And then suddenly the lake dried up, and it's now a really flat, dry bed. And people still do live there, but they can't rely on it for water or for food. This pod here has a graph on it that shows what carbon dioxide and temperatures have done between 1750 and 1950. This is the time in which humans really started burning fossil fuels for energy. The Industrial Revolution started, and we really started getting into those coal, oil and gas. And you can see that there's a very gentle rise happening there. Now, this pod is devoted to looking at the science of climate change, how scientists know what old climates were doing, and there are messages left in long-lived species like trees, corals, and stalactites. Although they're not alive, they actually record what the climate is doing at the time that they're formed. If you look carefully at the end of the stalactites, you'll see rings there that grew as the stalactite grew, and you'll see layers of minerals that were deposited, when there was heavy rain or during drought, the rings were smaller. So similarly with the coral is actually, it's a living organism, but it's a whole colony of living organisms. So it starts off very small, and then you get a whole lot of little polyps growing on top of that, and when they die, a whole lot more grow on top, and it just keeps on growing and growing. These particular corals can get to be meters big. And you can see here the lovely rings that have grown in this particular coral. This is a piece of hardwood tree. Kids will pull hard on that. They were yesterday. But if it breaks, we can get another one. It's easy to do. Now, down here too, we have a graph showing you. This is a very small condensed version of this large graph. It's a complete version showing from 400,000 years ago to today. If you look at that blue line there, that shows you where we've sent carbon dioxide to. And this is what scientists are worried about. You can see that temperature follows carbon dioxide. They're worried that we're going to go screaming up there, and we will actually heat the planet to an unlivable stage. A diagram here shows you how a fossil fuel is made. Fossil fuels were formed from ancient forests that lived and died and then were compressed to form coal. When plants take in sunlight and carbon dioxide, they convert that carbon dioxide into sugars, which they store in their bodies. When they die and are compressed to form coal, they take that sugar with them. And so when we burn the coal, we're releasing the energy from that sugar in that coal. And that's why we call them fossil fuels, because they were plants originally. But these little sheep here are a very entertaining rendition of what climate change is all about. They're really suitable for kids. Adults enjoy them as well. And it's nice to have a light touch with such a fairly serious subject. This pod here is it's very similar to the approach we took in the last version of Ecologic. We're looking at our use of resources on Earth and saying it's far better to reuse materials and to recycle them than to make them from scratch. We have the lovely crushed car that everybody loved so much before, but this time we have some iron ore, which is a raw material for making cars, raw material for making steel. So we're just showing people that that this is where it comes from. It makes no sense at all to go back there to make steel when you could actually melt down that steel in that car to make another one. You save 75% of the energy when you do that. In the last exhibition, we also had that huge population counter. This time we've got it on screen here, but not only do we have population, we have the number of mobile phones sold today, the number of cars sold this year, the amount of solar energy falling on Earth, the amount of I think it's the amount of fossil fuels being burnt on Earth, and it's live data, and it's really, really interesting there for you. Behind me you can see the carbon cycle, which explains again how the fossil fuels are burnt and how they release their carbon out to the atmosphere. Plinth here has a really sweet little model of a solar system there, and I've put it in there to talk about the fact that it took 400 years for the general public to believe and to accept that Galileo and Copernicus were right about the Earth going around the sun. These two scientists were persecuted by the church because they contradicted biblical scriptures. Galileo was actually under house arrest for 8 years before he died. Now, this is a concept that is accepted completely today. The Earth moves around the sun. But I've put this in here to say not everybody is comfortable with scientific ideas. Unfortunately, we don't have 400 years to debate the causes of climate change. So the whole issue moves into the realm of risk management. What should we do? Economists have told us that it will cost us $2 per person per week to reduce our carbon. It'll cost us $2 per week per person to reduce our greenhouse gas emissions by 50% by 2030. So, is it worth doing? What do you think? Are you ready to take the risk that all the climate scientists are wrong? I'm not. But that's the question we pose to the visitors. We're not there saying you are wrong, we are right. We're saying, what do you think?